Hey guys, this side Anirudh. I'll be your trainer today. So we have few sessions that we already gone through for BGP. So welcome to the next session. Let's go on.
Fine. So again we are going to start this BGP, and I hopefully today we are going to finish it. So first of all, today I'll teach you ORF, outbound route filtering. Outbound route filtering. See, the problem is, let's say, just try to understand that here this BT is giving some prefixes to R5 as well as R6, which is customer router, customized routers. Good. Now, if you talk about the global BGP table, in global BGP table we are having like 100,000 or more, 100,000 routes or more than that. So if you are having an internet connection, then ISP will share its global BGP table with you. Now, some of the routes will be completely unusable for you, right? Now you wanted to receive some prefixes only from your ISP. Now you have two options to achieve that. Either you perform route filtering at your own end for incoming updates, or ask your ISP to perform route filtering in its outbound direction. It's not it towards you. You can also ask to your ISP to transmit, to advertise only those prefixes which are required. Are you getting a point or not? Tell me. In both cases, there is a problem. Like, if you are performing route filtering by your own for incoming updates, then your CPU utilization will be higher, because your CPU has to filter all those prefixes to whom you have denied, right? Are you getting my point or not? So if you are filtering BGP prefixes by your own in inbound direction, CPU utilization will be higher. It means there will be a problem. And if you are asking your ISP to perform route filtering in outbound direction, it's good, but in case in future if you need some more prefixes, or you want to filter some more prefixes, then you have to ask to your ISP to do modifications, to do changes. And again, if you are asking to your ISP to make some changes, they will work as SLA. That's the problem. So in both cases you are having problem. In BGP, what are we having? There is a feature which is called ORF, outbound route filtering. Customer will configure prefix list. Customer will create a list at its own end, but it will be applied at the end of ISP. So that if customer wants to filter prefixes, customer will do modification, will do changes at its own end. It will not require to ask ISP to do changes. If you wanna allow, you can allow. If you wanna filter some prefixes, you can filter them by your own, even without asking your ISP. And that filtering will not be done by you, by your router. It will be done by ISP itself. Are you getting my point or not? So this is called outbound route filtering in BGP. So I'm going to do that now. See, this time, guys, just try to understand. This is R6. R6 is receiving all these prefixes coming from BT. Right? Now, if I perform route filtering with using either distribute list, prefix list, or filter list, it will be performed by R6 itself. It means its CPU utilization will be higher. In place of it, now I'm going to configure outbound route filtering. To configure that, first of all, you have to enable that capability in BGP in between these two neighbors. So say router BGP neighbor 201.100 and then say capability. Which type of capability? ORF, outbound. So from here you have to set it, right? Because here at the end of customer you will create your prefix list, you will send it in the direction of ISP. So you will say that I wanna send only, I don't want to receive. If you are working as ISP and if you wanna receive prefix list from your neighbor, then you have to enable that capability to receive prefix list. Even you can also say, but in this case I will simply require to send it from here. Then I will move back on New York router, sorry, on BT. And on BT, router BGP 35500, neighbor is 201.100.100.6. Receive, because it will receive it. And do one thing, say clear IPBGP start. Just reset your neighborship, hard reset. Fine. Let me show you now this command over here. Show IPBGP neighbor 201.100.100.6. You see, fine. So this capability has been enabled now over here. Like by default these capabilities are enabled in BGP. One, address family IPv4 unicast, and second was route refresh capability. These two capabilities are by default enabled, but you can also enable ORF capability. So we have enabled this time ORF capability in BGP. Fine. After enabling this capability, see, I will not do any configuration at the end of BT. ISP will require to enable this command only for the customer, right? Then after I will move back again at the end of customer, which is R6. Do show IP BGP, check it out. Create prefix list. Wait. Of course customer will filter prefixes, right? So we can filter anyone. 4 prefixes are coming. You can filter 101, you can filter 102, 100 or 103. That's what I'm saying, that customer wants to perform route filtering now. I'll create prefix list at the end of customer, but it will be effective at the end of ISP. So create IP prefix list, filter, deny. To whom you wanna filter out? Permit less than equal to router BGP 65500 neighbor 201.100.100.1 prefix list. Name is, here you will configure it in inbound direction, but you will see that it will be applied at the end of BT in outbound direction automatically. By doing configuration, it will look like that we are configuring filtering at the end of R6 only, and it will be effective on R6 only. But to confirm it, what will I do? What will I perform here? You see, so first of all, say clear IP BGP start now, and then after check its BGP table. Is there 102 now? Now you need to confirm whether it is filtered by R6 or it is filtered by ISP itself, and that can be confirmed from the end of ISP only. So move on BT, and you see, first of all, this command is there, show IP BGP neighbor 201.100.100.6, and then you can say, is it advertising 102? Is it advertising 102? It means it is filtered by BT itself. However, prefix list is configured at the end of customer, but the effect of that prefix list, effect of that filter list is coming on BT. Even you can also configure this command neighbor received prefix filter. Enter. So it have received these entries from its neighbor, and automatically it will be applied in outbound direction. However, at the end of R6 you applied it inbound direction, but here it will be applied in its outbound direction only. Even you can also see this command show IP BGP neighbor 201.100.100.6. Sent 3. ORF prefix list is what? 1. All these things are there. See. यार रिसीव्ड राउट क्यों चलेगी कमांड R6 पे? क्यों भूल रहे हो? कल बताया था रिसीव्ड राउट क्यों चलेगी? रिसीव्ड राउट कब चलेगी? जब सॉफ्टवेयर कॉन्फ़िगरेशन इनेबल करा देते हो. Fine. So this is done by BT only. Now if you want to modify it, let's say, then you also decided to filter out 103 as well. So now you say do show run pipe section IP prefix. IP prefix list filter sequence 6 deny show IP clear IP BGP star show IP BGP, and it is done by BT itself. Move on BT, configure this command received prefix filter C and advertise routes. This is called ORF, outbound route filtering. Fine guys, great. Now move again back on R6, router BGP 65500. Clear IP BGP star, and you will see again it will start to receive all prefixes. So IP BGP, you see. So you have received all prefixes from your neighbor now. All prefixes are there. Fine. Okay. Then after it, let's talk about BGP dampening. BGP dampening, route dampening. It is always required in BGP that your BGP table should be consistent. Sometime what happens that your interface will start flapping actually. So if flapping is occurring, interface will come up, will go down, come up, will go down. And if changes are occurring frequently in your global BGP table, CPU utilization of all devices of all routers will be higher. It can create a big problem in your network. To solve that, here in BGP we are having BGP dampening. In dampening, what do we do actually? Let's say that you have enabled dampening, and dampening can be enabled on in BGP for all prefixes as well as for some specific prefixes as well. After enabling BGP dampening, in case if any prefix goes down, if any interface goes down, of course it will not advertise it towards any other peer. But the thing is, BGP router can set a penalty for that prefix, can set a penalty and can put it into its history. However, it will not advertise that prefix towards any other neighbor, but in its locally router will keep that in its history so that it can keep its penalty value. Whenever it will come up, it will start to advertise it. If it goes next time, once it goes down next time once again, then again it will set its penalty. And there is a, in dampening there is a limit that okay, if your penalty reaches this value, then after, even if your interface comes up, BGP will not advertise that prefix towards its neighbor for next some time, for next time period like of 5 minutes or 10 minutes or 20 minutes. It will be depending on the penalty value, right? So once you will reach that penalty value, that limit, in that case BGP will start to suppress your prefix. It will suppress it. It will not advertise it towards its neighbors. So in case if your interface is flapping, it is coming up, going down, coming up, going down, you see that 1 or 2 or 3 times it will 2 or 3 times there will be an effect on your BGP table, but then after there will not be an impact on your BGP table. So just to have consistent BGP table only, we are having BGP dampening feature. Let me show you now. Now the thing is, like if I am on New York router is giving it to BT is advertising that those prefixes towards all others, right? But the problem is for New York router BT is eBGP neighbor, and for eBGP neighbor the minimum time interval between 2 consecutive update is what? 30 seconds. So what can we do? We can change this timer by using this command, router BGP 8127 neighbor 80.1 . Now I have configured advertisement interval is what? 1 second. Fine guys, good. Now see, try to understand now. In case if your loop back 1 goes down, you will see New York router will immediately inform to BT, so I'll be busy. Does it have? Oh, it is having it. Don't worry, it will be removed from here. It is still there. Just wait for a moment. New changes will take place. My God. One. If it comes up, came up. Is not it? If it goes down once again, So very first time it will not be effective, but then after, see, right? Now within 1 second it is giving an update to its eBGP neighbor. You see it have came up now. Fine. But see, BGP table is keep on to change because the interface of Neo router was flapping. Is not it? And if the BGP table of BT is changing, it means the BGP table of R5, R6, Sprint US, all routers BGP table will get changed frequently. Understood? To solve this problem, we are having BGP dampening. So now I'm going to enable BGP dampening onto BT. Let me move on BT now first of all. And router BGP 35500 and BGP dampening. This is the command to enable BGP damping. After enabling BGP dampening, let me show you IP BGP dampening parameters. See, these are the default parameters of BGP dampening: 15, 750, 2000, 60. These are the default parameters. What does it mean? Suppress penalty is what? Means that if the penalty of any prefix reaches 2000, your BGP will suppress it. Do you understand the meaning by suppress? It means that it will not advertise that prefix towards other neighbor. However, that prefix will be available over there. I mean, the interface will be up, but still BGP router will not advertise it towards any other neighbor. Reuse penalty is what? Once it has been suppressed, then it will be reusing that same prefix once its penalty will reach 750. Maximum suppress time, BGP can suppress any prefix for maximum 1 hour. And maximum suppress penalty can be 12,000. Forget about it, we don't need to worry about that. We just need to know about suppress limit, which is by default 2000. Reuse penalty, which is by default 750, means once the penalty of any prefix will reach 750, it will start to reuse that prefix, right? And
2000 के बाद वो reset हो जाती है.
What reset?
Reuse. Suppress penalty.
I didn't say that it will be resetted after 2000. I said that it will suppress that prefix once its penalty will reach 2000. And it will, BGP will keep on to decrease its penalty by using its decay time and all these things, right? It's not that its penalty will always remain 2000. No, if your interface have become now consistent, let's say now it have stopped to flapping, right? So its penalty will keep on to decreasing, and finally it will reach 750. But if it is still flapping, then its penalty will not decrease. Its penalty will keep on to increase, and it can go up to 12,000. Fine, guys. Now let me show you. Let me prove all these things. Show IP BGP. Show IP BGP 192.168.100.0. Let me show you. Is there any penalty? No, because after enabling dampening, I have not shut down any interface, right? So move back again on Neo router now. Say shut down. Let me move on BT. On BT, see, it has put it. It have not removed it. It will keep that prefix. See, BT is keeping that prefix, but in its history. But BT will not advertise it towards any other neighbor now. BT will not advertise it towards any other neighbor. As you can see here, show IP BGP 192.168.100.0. Check it out. history entry, not advertised to any peer, because it is history in its this entry is in its history. Penalty is what? So if your interface flap once, if it goes down once, then its penalty will be 1000. If it flaps 2 times, its penalty will be 2000. But see, it is keep on to decrease. See, 984, 965. Slowly it will keep on to decrease, right? Now, in case if this interface comes up once again, see, show IP BGP, it have started to advertise it towards other peers as well. Show IP BGP 192.168.100.0, but still it will keep its penalty value. Remember, if interface comes up, then its penalty will not be increased. Penalty will be increased in that case only when interface goes down. So this time it have started to advertise it towards others as well. And now after it, you do one thing. Move back again on New York. So IP BGP, once again it has put it in its history. And you see penalty is what? 1926. It have not reached 2000, right? That is why if this interface comes up once again, it will start to advertise it immediately. See, it have started to advertise it, but it will keep its penalty value. See, 1918. And then after, you can move on R6 as well. You can find all those prefixes, right? There is no problem. See, oh, it will come up, don't worry. So IP BGP, because here advertisement interval is by default. See, it is there, right? Even you can move on R6 as well. You will also find this one over there. See, right? So this BT is advertising towards all, but also BT is keeping that penalty value. Now next time, third time, if on New York router once again it has gone down, see what will happen on BT this time. So IP BGP will put it in its history, but this time see, its penalty has reached 2000 and it has flapped 3 times in this time. Fine. Now if you move back again on New York router and if you say no shutdown, it will again give this update to BT, but see this time what will happen. It have not put it in its history. What has done it? It has made it dampened path. It has defined this path as a dampened path, and you see, so IP BGP 192.168.100.0. You see, it is what? Not advertised to any peer, suppressed due to dampening, and penalty is what? 2806. It will start to reuse this prefix after 6 minutes and 39 seconds.
Thank you so much, guys, for watching my video. So we'll be coming back with few more videos of the BGP. Please subscribe my channel. That's @ARC_tutorial. Thank you so much, guys. See you in next video.